when working with absolute values, understand this is the definition. Absolute value is a magnitude, or represents a magnitude. It's the distance from zero that a number is that's inside the absolute values. So the absolute value of 7 is 7 units from 0, and the absolute value of -7, also 7 units, just in the opposite direction. And so that's what this definition means, and really what you're doing is, if the value that's inside the absolute value is a non-negative value, you just remove it. If it's a negative value, then you change its sign or take its opposite. Just when you're working through these, be really careful with where the absolute value symbols are. So here we see that there's a set of absolute values here and a set of absolute values here. So inside this set, we have 4 minus 20 using order of operations. And inside here, we have 4 times 3, which is 12 minus 6 inside that second set of absolute values. So we get a -16, and here we get a +6. And so absolute value of -16 is just the value 16. Absolute value of 6 is still just 6. So 16 minus 6 gives you your answer, 10. All right, so performing basic operations, again, is just a matter of keeping track of your negatives. In expression up here, a -10 squared, that negative is part of the base being squared. So -10 times -10 is +100. In the second example with the odd power here, again, the negative is not part of your power. Right? So you'll take 3 to the 5th, and 3 to the 5th. You take 3 to the 5th is 243, so the negative is going to stay, and you get your answer 243. Now notice in the second example here, or this third example, you have -3 to the 4th. Again, the negative is not part of the base being taken to the power of 4. So 3 to the 4th is 81, and the negative is going to stay out front. Now, had this been -3 to the 4th, now the negative is part of the base, meaning when you take it to an even power, it's going to become a positive number. And so be careful with the signs. This is an example where the sign really won't matter, whether it's with an odd power. It doesn't matter if it's inside or outside the exponential base. So -2 to the 5th. Again, we know our answer is going to be a negative. 2 to the 5th is 32, and because the negative is also taken to an odd power, it will stay a negative. In the problems like this example here, and if you're told that d minus z is 14, basically what you're being asked to do is rewrite these expressions so that you have d minus z in each one. So the first one, it's already d minus z. We can replace that with a 14, giving us multiplied by the negative. We get -14. In the second example, we need our z to be a negative and our d to be a positive. So I'm going to take out a negative sign, making this a -z and a +d. And if I reorder those, -d minus z, d minus z I can replace with 14. So once again, we get -14 for the answer here. And then the following, or the last one,